Okay, hello, Mr. Bossert here, and talking about cyclic numbers. We want to take some notes and see how this part goes. So, if I take a look at the spinner that I have here on the screen, right? Um, Spinner, starting with the indicated color and going clockwise, what order do the colors appear? Well, it looks like I'll call that blue. So it looks like they blue, green, red, and then orange. If I spin it again, alright, we got red, then orange, then blue, then green. Okay, if I spin it again, we got orange, blue, green, red. We get the idea that the colors are going to appear in the same order, right? But just starting at a different color each time, because it's just a cycle that will repeat over and over, and that there are 4 items in this cycle, right? So a cycle is something that repeats over and over, and we're going to talk about how this applies to numbers. I wanted you to see if I can hide this. Don't act like you didn't see that. If I wanted you to compute the decimal for 1/17th, how would you do it? Alright, you would take 1 and divide by 17. Now on our calculator, let's see if we can get a calculator up here. Alright, so if I have a calculator, bring this sucker up here. 1 divided by 17. How do I do this? Alright, you see that it, oh, look at that. That's pretty awesome. Okay, so it gives me 0.058823529411767. Alright. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 digits here. Now, does anybody guess, does this number, does this decimal end right here? Raise your hand if you think this decimal ends right here. Okay, that's 1. Alright, raise your hand if you think the decimal does not end right here. Yes, it does not. In fact, it repeats, and it repeats right here. So the next digits in the decimal, that's not what I want to do. Go away. And I don't think it'll show me anymore. But the next digit in the decimal would be 0, and then 588. Two, 3, 5, 2, 9, 4, 1, 1. Blah 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 blah. So, if we were writing this, we could write the bar over the 0 and then ending at the 7 here. Okay, well, this is what this number in green is, the whole number version of that. Obviously, see there's no decimal point here in front of it, and normally wouldn't lead to the 0, but the 0 is important when we talk about this next part. Okay, moving along. So a cyclic number, right, and this is an example of a cyclic number. This would probably be the easiest one that we deal with. 142857. All right, 142,857. And it is the same digits. It's not the same number. It's the same digits that is the equivalent of 1/7. So you look at this decimal, 1/7. You probably know that one. Maybe you do. 1/7 is 0.142857 repeating. 2/7 is actually 0.28 5714 repeating. Okay, and so who can tell me what 3/7 is? 3/7 is 0.42857 repeating. 4/7 is 0.571428 repeating. You can see that the pattern is that these same numbers, right? These same 6 numbers keep repeating themselves in the same order, but starting with a different number. Okay. So I've got this really fun spinning wheel for the cyclic number 142857. Now it's a cyclic number not because of that decimal thing, but it's a cyclic number because of this next part that we're going to talk about. If you took 142857 and you multiplied it by 3, all right, let's take a second to do that. Is 428,571. And again, it's the same numbers in the same order. All right, it would be if you look over at the wheel, if you started the number with green, so 428,571. If you multiply the number, and I'm going to spin the wheel here because this seems like fun. All right, this is the cyclic number 128571 times 1. It's 142857. All right. If I spin the wheel again, this actually gives me the number multiplied by 4. If I took the cyclic number, where are you? Can we get the cyclic number? There we go. And we multiply that number by 4. Be 5, if you take a look over here, red, 571428, 571428. Pretty neat. And if you took the number and multiplied it by 6, right, it would start here in the purple, 857142. Same numbers, same order, just starting with a different number each time. All right? So we actually don't need to multiply, we just need to figure out where the number should start, and then we'll figure out, we'll have the answer to the multiplication problem. But a funny thing happens if you multiply the number by, remember this number was generated from the digits that are in the repeating decimal for 1/7. And so if I multiply this decimal by 7, I would get 7/7 or 1 whole. But if I multiply this cyclic number by 7, right, what do you get? Well, you get 9. It's 49, carry the 4, 35, 4 is 9, carry the 3, 56, 3 is carry the 9, or it's 9, and carry the 5, 14 and 5 is 19, carry the 1, and so you get something pretty cool. You get 9999999, all 9s. So it's almost like if you multiply this together, you should get 0.999999 repeating, or 0.9 repeating. But we don't. We get 1. And so this is an interesting thing, right? I think I'm about to blow your mind for the first time this year. And that's to say that this number, 0.9 repeating, does not exist. You cannot find it anywhere in the wild. You cannot generate 0.9 repeating. It does not exist. That number does not exist because it's 1. Pretty interesting. We'll talk a little bit more about that later. Okay, so this was my number from before, and this is the digits that were in the decimal for 1/17. It's a repeating decimal for 1/17. Now this is the whole number version. All right, these are whole numbers, but I do have the 0 in front because it is part of the cycle. So this is not the decimal. It's not a repeating decimal. Now as a whole number, it is a cyclic number. And so if I took this and I multiplied by, let's multiply by 3. Okay. Well, if you just start multiplying by 3, so you get 21, carry a 2, 12, 14, carry 1, 3, 18, and 1 is 19. So can you pick out where the cycle ends? All right. We scan through this number here, 941. All right, those are the last 3 numbers. So my number ends here. So this right here is actually going to be the start of my number. So without doing all 16 multiplications, I know I'll just start the number right here. I know the answer is going to be 17647, and then go back to the front here, 058825. I'm sorry, that's a 3, isn't it? 23. How do I undo that? Oh, crud. Okay, 058823522941. Because again, I know it's a cyclic number because it's generated from that repeating long decimal. And I knew it ended in 941 because I did the first couple multiplications. So that has to be the end of the number. So this one is the start of the number, which is why I started here. And then I just wrote the number. I didn't have to do the multiplication. All right. So if I wanted to multiply it by 8, well, 8 times 7 is 56. So, and if I look, this is the only 6 in the whole number. So I know right away that that is the end. All right. The 6 is the end of my number, which means that the 4 is the start of the number. So the answer is going to be 47, and then write the number 05882352941176. Again, if I multiply this by, let's say, 7. Anybody have the answer? Anybody? Yeah. 7 times 7 is 49, so this number ends right here in the 9. So the start of it will be 4117. So 4117 0588235229. My spacing's off, but you get the idea. Anybody knows what happens if you multiply this number by 17? Because remember, it was generated from the decimal, repeating decimal numbers for 1/17. If you multiply by 17, right, it's not 1, it would be all straight 9s. So this number is going to be 16 9s. That would be the answer. You go ahead and multiply it out. I'm assuming somebody who is not trusting soul will probably try to multiply this out, or with a calculator you can try to do it. You get straight 9s. All right. So the questions that you need to ask and answer: what is a cyclic number? How are the digits formed that make up the cyclic number? And how can you determine the number of digits that will be in the cycle? Alright, this was our first attempt at taking notes and doing the notes. We'll see how this goes, and then we will do. The idea would be then the next day we will do take these notes and we'll do work for it. Alright, thanks very much. We'll talk to you soon.